So chapter 5 is all about factoring. The concepts that we learn in this chapter are some of the most important and most useful in this course, and we'll continue to build upon them in all of the following chapters. So let's start out with factor trees. This is our bonus section. So we're going to talk about greatest common factors and eventually factoring by grouping. So what a factor tree is it takes a number, a whole number, and we break it down into its smaller divisors until each branch ends in a prime number. And if I haven't said this before, the first few prime numbers are 2, 3, 5, 7, 11, 13, 17, right? It's always good to know the first few prime numbers. Factor trees need not look the same because there are different ways that you can factor. But you will always get the exact same list of primes. So 48, for example, we broke that down into factors of 8 and 6. 8 breaks down into a 4 and a 2. 4 breaks down into a 2 and a 2, and then these are all prime numbers, so I'm done. 6 breaks into a 2 and a 3, so now I have all prime numbers. So we can write 48 as 2 to the 1, 2, 3, 4th power times 3. So we're breaking things down into their prime factors. The greatest common factor, also known as GCD or greatest common divisor, of a set of whole numbers is the largest positive integer that divides evenly into all numbers with zero remainder. So for example, for the set of numbers of 18, 30, and 42, the greatest common factor, so the largest number that's positive that fits into 18, 30, and 42 is 6. So how do we find the GCF? To find the GCF, we're going to use factor trees first, so we'll make our factor trees. Then we collect all of the prime factors they have in common, i.e. we're going to be matching pairs, and we multiply these together to get the GCF. So let's take a look at 18, 30, and 42. I wasn't planning on doing this example, but here we go. So if I have 18, that's going to be a 9 and a 2, which is a 3, a 3, and a 2. 30 is a 5 and a 6, which breaks down into a 2 and a 3. 42, that's a 4 times 7. Nope, that's not. That's 6 times 7. Yep, 6 times 7, which is a 2 and a 3, and 7's already prime. So I want to collect what they all have in common. Well, 18 has a 3, 30 has a 3, 42 has a 3, 18 has a 2, 30 has a 2, and 42 has a 2. As you can see, the remaining primes of 3, 5, and 7 are have no partners, right? It needs to be in all three to be for this group. So then I would take 2 times 3, and I get 6, and that's going to be our GCF. So why don't we work through a few examples? So let's use factor trees to find the greatest common factor of 18 and 24. And then we're going to do an example with variables where we find the factor tree, where we find the GCF of 12x squared and 16x. Note that you do not have to use this factor tree method every time. If you can see right away what the greatest common factor is, good for you. Hopefully that's a skill set that we're able to build up to. Let's start by factoring 18. That's 2 times 9, which is 3 times 3. 24 is, I could write that as 2 times 12. I could write that as 4 times 6. It gets me to the same point. So let's do 4 times 6. 4 factors into a 2 and a 2. 6 factors into a 2 and a 3, and then I'm done. So let's collect the factors that they have in common. So 18 has a factor of 2, and so does 24. 9 has a factor of 3. Sorry, 18 has a factor of 3, and so does 24. Are there any more matches? No, so we're going to take 2 times 3, and that will give me 6. So the GCF of 18 and 24 is 6. Let's do another example with variables. We're still going to make factor trees, but we're going to break apart our variable portion as well. So instead of 12x squared, I'm going to have factor that into 12 and an x squared. X squared is 2x's. 12 is 4 times 3. 4 is 2 times 2. 16x factors into a 16 and an x. 16 is 4 times 4. 4 is 2 times 2. Break both those 4's up. Now everything ends in a prime or a variable of degree 1. That's important. So we're going to collect what they have in common. Well, 12 has a factor of 2. 12x has a factor of 2. 16x has a factor of 2. I've got another factor of 2 at 12x squared that I can match over here. I've got a factor of x, which I can match over here. And then there's no other remaining matches, right? 12x squared only has an x left. And I've got two 2's left at 16x. So I'm going to multiply these together. So the GCF is going to be 2 times 2 times x, which is 4x. So the greatest common factor of 12x squared and 16x is 4x. Quick note that the greatest common factor of any two prime numbers or factors is 1. So 5 and 7, those are primes, right? We can't break them down any further. It's 1. And for example, the GCF of 3xy and 2a squared is 1, because if you pull those apart, right, I'd have 3xy, which factors into a 3 and an x and a y, and 2a squared, which factors into a 2 and an a and another a. They have nothing in common, so the greatest common factor is 1.